Now, let's discuss an identity, which we discussed identities last week. I just wanted to discuss one more. All right, one more. Let's take a look. All right, so here's an identity where I'd like to take 1. All right, so we got 1 plus the cosine, 1 plus the cosine of 2 theta minus 1 minus the cosine of 2 theta. And this problem says that this is equal to the cotangent of theta. Now, identities are different. This is not an equation. You're not solving for theta. What you're doing is you're taking something that looks very, very, very demanding, very confusing, and you're simplifying it down to something that is much more manageable. So the beauty of what we're doing is we've already shown you here that there are different ways to write cosine 2 theta. You're trying to get this to equal this. Now, if you know what cotangent is, cotangent is the cosine over sine by definition. So you're going to use your knowledge of that to choose which of these to use as you replace this cosine 2 theta. By definition, cotangent is cosine over sine, cosine theta over sine theta. So that said, to replace this cosine 2 theta, you're going to use the 2 cosine theta minus 1 because of the definition of cotangent theta. So what we have is we have 1 plus cosine 2 theta, which is 2 cosine squared theta minus 1. All right. And now that's over 1 minus cosine 2 theta. Again, your understanding of cotangent is very important. Cotangent is equal to the cosine of theta over the sine of theta. The fact that this has a denominator of sine theta is going to impact how you redefine cosine 2 theta. You want sine theta at the bottom. So now I'm going to rewrite this cosine 2 theta as 1 minus sine because of my desire to have sine in the denominator over here on the right. So now I have 1, that's 1, minus what cosine 2 theta is equal to, which is 1 minus 2 sine squared theta. All right? So now let's simplify this. This is 1 minus 1. So now we have 2 cosine squared theta. This 1 and that minus 1 cancels. Oh, I'm so sorry. You can't see that. Sorry about that. So now you have, in the denominator here, you have 1 minus 1 plus 2 sine squared theta. The 1 minus 1 cancels. 1 minus 1 cancels. And this is equal to the cotangent of theta. I teach my students never to touch one of the sides. I'm not touching that side at all. So now we have 2 cosine squared theta over 2 sine squared theta. The 2's cancel. You're left with cosine squared over sine squared. Let's see here. You're left with cosine squared over sine squared. And let's see what we've got here. Oh, boy. Oh, I'm sorry. The original problem, forgive me. I'm so sorry. The original problem was cotangent squared. That's why I hesitated there a little bit. I wrote down the problem wrong. So this is cotangent squared theta. And this is indeed cosine squared theta over sine squared theta is cotangent squared theta. All right. So I'm just showing you that the purpose of this exercise is to be able to simplify all this down to that. And we did that. The idea of this exercise is in a higher level math course, you might be asked to do something with that. I don't know, maybe take a derivative or antiderivative or something like that. It's so much easier to simplify this than it is that. So if you're able to take a challenging trigonometric expression and simplify it down so that you can later on do something with this, I think you can see that it's going to be so much easier for you to evaluate or take a derivative or antiderivative or something like that, graph this as opposed to this here. All right.